Welcome back. Chapter 3, Ohm's Law. Okay, so Ohm's Law. What is Ohm's Law? First of all, I'm sure you remember from class, I defined our resistors as being measured in ohms. Ohms having the symbol, Greek letter omega. Okay, you see that after some numbers, that's measuring a value for resistance for that particular thing. Okay, that particular device. All right. You set your multimeter to the ohm function. That's measuring resistance. Okay. So what is that? What is it doing? How much of this do we need to know? So Ohm's law defines resistance as voltage divided by current. Okay. There's several different ways we can turn this around. Okay. We can turn this around by saying, how do we set this equal to voltage? Okay, we'll set this equal to voltage by saying the following. Voltage is equal to current times resistance. Okay, current times resistance. And equally, we can set it equal to current as well. We can say current is equal to voltage divided by resistance. Okay, voltage divided by resistance. Those are the three ways you can turn this formula around. One quick and easy way to apply this anytime you need is to follow this triangle plan here. Putting voltage up top, current, and resistance in the bottom. Okay? Now, I'll show you this as an example in a little bit. But first of all, before we do, let me tell you that if you're trying to find voltage here, simply cover voltage and look at the two that you have, current times resistance. It lines up with our mathematical formula, current times resistance. If you're trying to find resistance, cover resistance, you'll see voltage divided by current. Lines up with what Ohm's law defines resistance to be. Okay? So, let's see that in action, okay? Let's see that in action. So if we have a battery that has 4 volts, okay, and we have a current of 0.5 amps or 500 milliamps, same as 0.5 amps. What type of resistor will we need to provide this 0.5 amps, given our particular potential as being 4 volts? Well, what do? We say voltage divided by current is equal to resistance, right? We'll plug it into our triangle here. We have a 4 for voltage, we have a 0.5 for current, and we need resistance, okay? Cover resistance, we get 4 divided by 0.5. We need a resistor of 8 ohms. We need a resistor of 8 ohms, okay? That is the formula, okay? There's one way. Of course, I could put one in for resistance and solve for current as well, but this basically outlines it for you, okay? So let me go over another way to solve for resistance. Resistance changes with the type of resistor that you have, and it is directly proportional to, I'll define it by the words that you see in your lecture text, but it is directly proportional to the length of the resistor and indirectly proportional to the area of the resistor. What does that mean in terms of English? Using English, what does that mean? That means as a formula, don't pay attention to this thing just yet, but L divided by area, length divided by area, okay? So that means that however large you make length, that means that R is going to get bigger. However large you make A, resistance is going to decrease. Wait, it's going to decrease. How does that mean? That means because, say you have an area of 4 centimeters squared, and you have another item that is 6 centimeters squared. Well, if you have that combination and the lengths are both the same, then that would mean that that thing has a greater resistance. Okay? that thing has a greater resistance than that thing. Okay, because 1 over 4 is much larger than 1 over 6. As our denominator gets larger, as our area gets larger, the overall resistance becomes smaller. Okay? However, if the length gets larger, the resistance grows with it. All right? Now, to this other thing, that P-looking letter, that's called resistivity. Resistivity. And it changes with the different type of material you use. So different resistors are made of different materials. Some resistors are made of carbon, some made of foil, some made of nickel, some copper, different materials, all types. And all those different materials, I can't go over them all, and I don't have a table in front of me to tell me what each one is, but I'll be providing it on the D2L side. But resistivity changes with the different type of material you use. Okay? So, and the resistance overall changes with it directly. Okay? Resistance changes directly with resistivity and length, and indirectly with area. Okay? All right, now look for these examples on D2L and look